Hey everyone, today we'll go over problem 2 of the FA25 midterm 1. So looking at this problem, we're given a data set of n equals 8 values from y1 to y8 and a constraint on our alpha value that is greater than 4 and less than 20. So we can write out this data set off the bat. So the first term is 1, the second and third are both 4, the fourth through sixth are alpha, and the seventh and eighth are both 20. And we can also define our absolute of W function as 1 over 8 for n equals 8 data points times the sum of I equals 1 to 8 of the absolute value of yi minus W. And to reiterate, this is the mean absolute error of predicting a constant value W. So moving on to part A, let's remember a key fact about MAE is that the constant that minimizes it is the median of the data set. So we can write down median minimizes mean absolute error. Now we just need to find the median of our data set right here. And to do this, we can see that it'll be the average of our fourth and fifth points, which are both alpha. So we can find the average of these two by adding them, dividing by 2, which is 2 alpha over 2, which is just alpha. So our W star is equals alpha and is unique because we could find an exact value for it. Moving on to part B, we can compute the minimum value of the function by plugging in alpha for W. So our abs of alpha is equal to 1 over 8 times the sum I equals 1 to 8 of the absolute value of y1 minus alpha. And from here, we can expand this summation. So this would look like for y1 is equal to 1. So we can plug that in. 1 minus alpha, absolute value of 1 minus alpha plus y2 and y3, which are both 4. So we can write that as 2 times the absolute value of 4 minus alpha plus the 4 through 6 terms, which are all alpha. So we can write this as 3 times the absolute value of alpha minus alpha plus the last two, y7 and y8, which are both 20. And we can write that as 2 times the absolute value of 20 minus alpha, all over 8. So we can see that the 3 terms here, alpha minus alpha is 0. So we can cancel those out and simplify this down further. We get these terms remaining in the numerator, all over 8. And now using this constraint that we're given right here, so 4 is less than alpha is less than 20. We know that the absolute value of 1 minus alpha is equal to alpha minus 1. 4 minus alpha is equal to alpha minus 4. And 20 minus alpha is equal to 20 minus alpha. Because these values on the right-hand side have to be positive, they must be true because of this constraint. So substituting this back into the numerator, we get alpha minus 1 plus 2 times alpha minus 4 plus 2 times 20 minus alpha over 8. And expanding the terms, we get alpha minus 1 plus 2 alpha minus 8 plus 40 minus 2 alpha over 8, and we can simplify the terms. We get alpha 40 minus 9 is 31. So alpha plus 31 over 8 is our answer. So this value is the minimum of the MAE function. So we can rewrite this as let m represent the lowest possible value. So m is equal to r abs alpha is equal to alpha plus 31 over 8. Now moving on to part C. We'll follow this hint that it's possible to answer this without using any of our work or answers from the previous part. So in order to do this, we'll use the slope method. So first we're told that our abs of 20 minus m, which is the minimum possible value of r abs w, is equal to 9 over 2. So we have to find that m is equal to r abs of alpha. So our statement here becomes r abs of 20 minus r abs alpha is equal to 9 over 2. So in English or in words, the MAE at W equals 20 is exactly 9 over 2 larger than the minimum value. So describing the vertical distance between the 2 points on the MAE graph, the minimum point alpha comma m and the point 20 comma r abs 20. Yeah, so this right here is describing the vertical distance between these 2 points. So the vertical rise between them is 9 over 2. So using the geometry of MAE, the slope formula is equal to the number of points on the left minus the number of points on the right over n. And here, for this problem, n is equal to 8. So the MAE function is piecewise linear, V-shaped, and with a slope determined by the counts of points to the left and right. So here, for the next step, we will count the points between alpha and 20. So we are moving from W equals alpha to W equals 20. So we'll first count the points strictly less than 20 from our data set, which is 1, 4, 4, alpha, alpha, alpha. And that's 6 points or 6 values. And then we'll count the points that are equal to 20, and that is just 20 and 20. So that's 2 values. So on this interval from alpha to 20, the slope is equal to 6 minus 2 over 8, and that's equal to 4 over 8, which is equal to 1/2. So for every one unit we move right, the MAE increases by half. So using the rise over run, we know that the vertical rise between those 2 points is 9 over 2. Our horizontal run is that segment, which is 20 minus alpha. And since slope is equal to rise over run, we have 9 over 2 over 20 minus alpha is equal to our slope. And from this earlier part, we know that slope has to be 1/2. So we can set that on the right-hand side. So now let's solve for alpha by first multiplying by 20 minus alpha on both sides. We get 9 over 2 is equal to 1/2 times 20 minus alpha. Multiplying by 2 on both sides, we get 9 is equal to 20 minus alpha. And then solving for alpha finally, we get alpha is equal to 11.